That was yesterday. Now here we are today, just under 4 minutes to launch. This is the program director in charge of the contract for Arianespace, and the head of the Galileo program department for the European Space Agency, and the director of navigation, the navigation department at the European Space Agency. Here we can see some shots there from our drone, which is flying over. It's been very wet here. We've had driving rain all day, and you can see heavy clouds there in the skies. But it seems to have cleared a little bit, so let's hope we get a reasonably good view before the launcher goes and hides behind the clouds. So far, we've been concentrating on the Mission Control Center that's in charge of the whole mission, everything across the range. But there's another control center. This is the Launch Control Center. And everybody here is in charge of the actual launch itself. So they are in a special building, often known as the bunker, because it's a concrete blockhouse. It's protected because it's only a few kilometers from the launch pad. Got about 100 people working in here. They deal with all the systems concerning the launch vehicle and the launch zone. These guys and girls started their preparations months ago, and right now their job is to make sure that the Ariane rocket is ready for takeoff. They're monitoring events during this synchronized sequence that Thierry was explaining back there. The computers right now are running all the final controls, and they have to coordinate an awful lot of checks in a very short period of time. And once all the conditions are correct, the onboard computer will give the order to start the engines. You've got a really good view there from the drone of the launch zone. You can see the tall building to the right is the assembly building. You can see those heavy skies over the spaceport. We heard earlier that we will be getting a 7-second delay, so you'll be able to count 7 seconds once you see the first ignition of the main Vulcan engine. That's because we need to check the main engine before we switch on
de DDO, attention pour moins 1 minute.
The boosters, coming up to 1 minute.
Top H0 moins 1 minute.
We are 1 minute to launch. We're live at the Arianespace Center for the launch of 4 satellites for Europe's Galileo satellite navigation constellation for the European Space Agency and the European Commission, built by a consortium led by OHB, and they're traveling on board the 240th Ariane 5 heavy lifter. Our very best wishes to all the teams. Let's sit back now and watch the launch.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain. Allumage des 2 EAP et décollage Ariane 240 Galileo FOC-M7. La propulsion est nominale. Tous les paramètres à bord sont
And
normaux.
there they go. blazing a trail across the sky here over the spaceport, the Arianespace Center. We're heading northeast out over the Atlantic Ocean, and we can hear the launcher as she flies over us here. We're about 20 kilometers from that pad. We reached Mach 1 after 45 seconds when we broke the sound barrier. And right now, it's the boosters that are doing all the work.
Tous les paramètres à bord sont normaux.
She's telling us that everything on board is going to plan. They are providing 90% of our thrust right now. That's the equivalent of 12 jet engines, and their job is to push us away from the gravity of our planet. We need a lot of firepower to do that. She's telling us that the propulsion is going normally. Each booster is burning 2 tons of propellant per second, and that's roughly the equivalent of what an average car would use in a year, and they're using it in a second. Unbelievably, those boosters are burning at roughly 3,000 degrees Celsius, and yet the main stage is burning cryogenic propellant, which is at absolute zero. It's the coldest temperature you can get. So you can just imagine the complexities of balancing and keeping those two temperatures next to each other, the extremely hot and the extremely cold. It's a feat of human engineering. And she's announcing separation now of those 2 boosters. We don't need them anymore, and they can be jettisoned. There they go. Those were cameras on a previous launch. We've lost about 3/4 of our weight. The lighter we are, the faster we can go. And we're now burning the main stage. It's that grey section. It's a huge tank of cryogenic propellant, which is liquid hydrogen and liquid oxygen. It burns for about 9 minutes.
Tous les paramètres à bord sont normaux.
And in a minute, we'll be looking at the launcher again, and we'll be able to see what we call the fairing. That's the front, the nose, if you like, of the launch vehicle.
La propulsion est nominale, tous les paramètres à bord sont normaux.
And she's telling us that everything is normal. Everything's going according to plan. So there you can see the fairing. That's the nose, the pointy bit of the launcher, and the fairing is the section which protects. And this protects the launchers, the satellites, from the riggers of the launch. Those riggers include the acoustic vibrations at liftoff. You can just imagine there that it's very loud. So our satellites are now exposed to space. We took off, you can see there, from the northeastern coast of South America, and Galileo is the... She's telling us that everything's going according to plan still. Galileo is the tracking station here at the Guyana spaceport, and you can see we're traveling northeast. SNA is the next tracking station to pick us up. That's a boat in the middle of the Atlantic, and then we'll be heading up towards the northwestern coast of Europe, and we'll be picking up the signal at the Azores. Let's find out more now about today's mission.
For this 11th flight of the year, Arianespace is proud to welcome the two-day Ariane 5 VA240 Galileo FOC-M7 mission to deploy 4 more Galileo satellites for the benefit of our customer, the European Space Agency, acting on behalf of the European Commission. Arianespace today reaffirms its company's important role in supporting European governments and institutions with independent, reliable, and available access to space.
This launch will place in orbit 4 more satellites in a series of 22 manufactured by OHB in Germany, embarking payloads provided by SSTL in the UK. 5 FOC satellite launches have already been carried out by Soyuz launchers, each delivering 2 satellites into orbit.
For this launch, a second Ariane 5 ES version dedicated to Galileo mission will be used, with in particular a different upper stage called EPS. The EPS storable propellant upper stage is powered by a reignitable engine that operates with MMH and 204 propellants, allowing reignition capabilities, essential for required Galileo mission performance.
This launch campaign started in mid-September 2017 with the arrival in French Guiana of the first pair of satellites. All 4 satellites have undergone a series of tests and preparation activities.
For recall, the specific dispenser carrying structure has been designed by Ariane Group, allowing to support 4 maximum satellite masses of 738 kg each, which cover with comfortable margin the actual satellite masses for this mission.
This campaign has led to additional needs in coordination and technical operations. All these challenges were surmounted through excellent preparation, planning and execution, the experience gained in the previous Ariane 5 launch campaign, and especially thanks to the very efficient technical teams.
Finally, I would like to thank all involved teams, and firstly our customer, the European Space Agency project team, the satellite manufacturer OHB, and the CNES-CSG teams for their very efficient collaboration and fruitful teamwork, which allowed to manage the program and the launch campaign with a great professionalism.
Indeed. 7 minutes and 24 seconds into launch, and today is the 56th mission that Arianespace will have performed for the European Space Agency. And during that film, we picked up the signal at the SNA tracking station. That's the one in the middle of the Atlantic, the boat. Bottom left is our altitude. We are 134 kilometers above our planet. The middle is the distance. That's if you were to draw a straight line along the planet from the launch zone to the position of the launcher. She's telling us there's 1 minute left of a burn on the main stage. And then on the bottom right-hand side, you can see there is our speed. We're traveling at an unbelievable 7 kilometers per second, not per hour, per second. And on the top right-hand, you can see there is our trajectory. That is the planned trajectory. And the white cross is the position, the actual position of the launch vehicle. Burning at the moment the main Vulcan engine. It's propelling the main stage, which is an extremely powerful beast.
Fin de propulsion de l'étage principal cryotechnique.
And we have switched off that
et séparation de l'EPC.
Engine. And we have separation there of the main stage, and we have switched on the engine now of the upper stage. So we're beginning the next phase of the flight. The
Premier
upper stage.
De l'étage à propergol stockable.
She's saying the first engine switch on of the upper stage. So the upper stage has taken the wheel, and its job is to transport our satellites to their correct orbit so that we can release them absolutely precisely onto their orbit, and from there they'll be heading off on their own in medium Earth orbit to their final slot, and they have to do that all by themselves. We have 3 orbits for anyone who's not familiar. Well, 3 main ones. We've got low Earth orbit, which is the nearest to Earth. We have medium Earth orbit, which is where these guys will be sitting, roughly 23,000 kilometers above our planet. And then we have an orbit called geostationary orbit. We're not using that one today, but that's where most of the telecommunications satellites sit, and that's 36,000 kilometers above Earth. The Galileo program is an important collaboration between ESA and the European Union.